Okay, here's the backside of Russell. Different toy car. This one's faster and has a different equation to calculate the distance that it travels. So we can use the equation on the back that has the graph of it to talk about the visualness of it. Here we are given a bunch of times, in this case x values, and they're different. There's not a bunch of them that start at 2, so we're going to have something that slightly different happens. But keep in mind these are just x values, so in this case this is 1 comma something and 4 comma something, and to figure out what that something is you got to plug these x values, or in this case t values, into your equation and calculate it. So 1 plugged into that guy right there will give you 2, 4 plugged into that guy right there will give you 20, and to calculate the average rate of change it's just the slope of the line that connects these two. So start with the larger one, difference of the y's over difference of the x's, and we're looking at 18 over 3, which is 6 feet per second. On our graph, just to show you, what we just did is found the slope of the line that connects that dot there, 1 and 4, that guy there. We just found the slope of that line, terrible line. That's what we just found. And that slope of that line is the average rate of change for the toy car. So you're going to do that now 10 times, which would be tedious because a lot of these are different x values. 3 gives us 12, 5 gives us 30, 30 minus 12 over 5 minus 3, 18 divided by 2 is 9 feet per second. Okay, so you have 10 more of those to do. Go ahead and finish those and press pause because I'm going to move on to number 5 right now while you're finishing those. Okay, you'll notice number 5, kind of like the number 2 on the other side, except this is not a 2. Now on the other side we used 2 comma 2 plus h because it was very practical. Because we had a bunch of values up here where the first coordinate point was a 2, it made sense to use this notation. But if you look at all these up here, there's no rhyme or reason to them. So x is the wisest choice for our starting value because the x is changing. It's different each of these problems. There's a couple that repeat, but choosing any random point is what this means. That means the first coordinate point is x, comma, something. Now how did we find the y value? By plugging in this x value into that equation. So we have to plug x into the original equation, this t squared plus t thing, and we would get this, x squared plus x. The second coordinate point comes from the x plus h. That's our x value. Now we have to stick x plus h into that equation up above. If I did that and not do anything else besides just sticking it in, I'd get that. I should write that as a coordinate point, sorry. So there are 2 very ugly coordinate points. Not as pretty when we actually had numbers. These are just with letters, with variables. And we want to find the average rate of change for these 2 ugly coordinate points. Now, this is what we're finding, just so you know graphically. We've got a parabola that we're dealing with. This is a coordinate point. It's any coordinate point on this graph that you want to pick. I didn't mark numbers here because I don't want you to think that that's a number. That dot right there has a x value of x. How do you calculate y values? By plugging the x value into the equation. So that coordinate point right there is this guy. Now, here's the weird one. You pick a second coordinate point out here, anywhere out here. How far past x do we go? Just like we did on the other side, we go h past it. H is a number. So we go this distance past this guy, and we get a new destination, which is called x plus h. So from here, from 0 to x is x. From x to this new random dot is h, which makes the total distance x plus h. Hopefully that makes sense. That means this coordinate point has an x value of x plus h and a y value of this ugly thing here, which you find by sticking it into the equation. Now, we have to find the slope of the line that connects these two random dots. So we do difference of the y's over difference of the x's, and we start with the ugly y. That would be this guy. So I'm going to start with this, and I'm going to go ahead and FOIL that guy to save some space. X squared plus 2xh plus h squared. That's just that part. We still have this plus x and plus h. So everything I wrote there, that's just the first y value. I now have to subtract the other y value. I better use parentheses so I can distribute the negative. All over. We go back to this x value, and we subtract the first x value, which is that. And now the tidying up process begins. This x squared minus this x squared will cancel, which is nice. This x minus this x will cancel, and this x and this x will cancel. So if I were to write everything that's left over, I'd have those things on top and still an h on the bottom. At this point, we need that h to cancel, and you'll notice all three things that are left up there can be factored. You can pull an h out of them, which would leave behind this inside the parentheses. These h's cancel. So what's left over is this expression. Now, what is this expression? This is the average rate of change for any two coordinate points on this graph, the t squared plus t graph. What that means is this will calculate the average rate of change, or the average speed of this toy car, for any two coordinate points you want to pick. So if we were to now use this expression for the values up above, if you'll notice the first one up there was 1, 4. If you think of what we just found, the expression x, x plus h, it should help you identify what the x and the h is. For example, if I want this to look like this, what would the x have to be? It would have to be a 1. If I now have an x value of 1, and I want to know what h has to be, remember this has to become 4. Well, I've already got a 1 right here, so what would the h have to be? 3. Or another way to think of it, h is the distance between that guy and that guy, so you can see the distance between 1 and 4 is a 3. Once you have those two values now, you can plug them into your expression for the AROC for any 2 points. X gets to be a 1, that would make it a 2, plus h gets to be a 3, so now we're looking at 6. And you'll notice 6 is what we got up above when we did it the long way, 6 feet per second. I have time to do one more here. We are working with 3, 5. So the x value is just the first number. In this case, it's a 3. H is the distance between those guys. It's a 2. Now we plug that into our expression there. We get 6 plus 2 plus 1, which is 9 feet per second. That's what we got up above. So continue to use that expression to check to make sure your long ways up above are all correct.